Can we see okay? Yeah? So last time we were doing exponential equations. And again, just like the last class, we're not going to do any new formulas. We're just going to look at using the log rules to help us solve equations. So let's just do some examples. I was just talking to Joan this morning. You know Joan?
Yeah.
Yeah, you know Joan, the other maths teacher. Yeah, there's still a lot to do in this semester and there's not a lot of time left.
But you can just a quick teach.
Ah, yeah, no, I'll get everything covered. There won't be any time for revision at the end. So I guess what I'm trying to tell you is, you maybe want to start thinking about looking at exam questions as preparation for your end of semester 1 exam. So I think it's like, John was saying it's like three-ish weeks left, about 3 weeks.
Yeah.
It's not a lot of time, You want to start thinking about doing some of your own personal revision, okay? Right, so log equations. Let's have a look at some examples. Log 5x equals 4. Can we figure out what the x is? It has to be 625, I think. I think so. Because log 5, 625. 5 to what power gives me 625? I think it's 4.
Yes.
It is, yeah. 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 So in this example, x is 625. This is a kind of a basic example. Yeah. Let's do a more interesting one though. Can you write this down? You got that? Okay, next example. Can you do the next example? Yeah. So look, this one is a bit different. Because the problem here is you can't change the 4 into 3.
Yeah.
I mean, you could change the 9 into 3 squared, right? But you can't change the 4 easily into a 3. Yeah? There are 2 ways to do this. I want to show you both ways. The first way, if your calculator has this button, which it should, is you look at this and realize, oh, I know what this is. This is a log problem. You're saying 4 to what power gives me 9? And the answer is log 4, 9. Because that's what log means. 4 to what power gives me 9? So it should be a decimal. But if your calculator has the option, you can type this in. What calculator do you have, Jason? Do you have a Casio? Can I see? Maybe that would work. This one, no, I want to see if his one can. That one certainly can, can't it? Yeah, this one can. Yeah, 1.585. Here you go. 1.585.
Teacher, is this calculated by hand?
No, you have to use your calculator here.
Okay.
For this one, you have to. The other way to do it is you have 4x equals 9, and what you do, you put any log on both sides. All calculators have an LM button. Oh, come on. What the heck? What's happened? Oh, it's frozen. Oh, here we go. Ah, come on. pen. There we go. That end. Now, we can use, what one was it? The third rule of logs, maybe?
Yeah.
The x here can come down in front. And then what should I do next? Now you might be confused why these two answers are the same, but believe it or not, this is the same as this, and you can make it the same if you use rule 6, the change of base rule. So, anyways, either method is fine for the exam. Now I kind of think, when I look at the marking scheme, they kind of do it this way. Not that this is wrong, it's just they kind of imagine students would do it this way. And that's how I used to do it, but then I realised, oh, all these calculators nowadays have the ability to change the base, which is quite convenient, right? Because you can do it quicker this way. Is that okay?
Yeah.
Yeah? Okay. Write that down and we'll do, now this one's a little too easy for the exam. Can I see what you typed? You close brackets. Can I scroll down? Yeah? Okay. So, let's have a look at another example. Six power x minus 4 equals 9 power 3x plus 7. Now it's very similar to the last one. In fact, I think I would like you to try it before I give you the answer, because I think a lot of you could do it already. Okay, how are we doing here? We got answers? Yeah? Okay, let's have a look. So, what I'm going to do first is... Where's my pen? Hello? Come on, let's go. There we go. I'm going to put natural log on both sides. So this becomes x minus 4 log 6 equals 3x plus 7 log 9. I'll expand now. X times log 6 is x log 6. 4 times log 6 is 4 log 6. 3x times log 9 is 3x log 9. And 7 times log 9 is 7 log 9. Taking the x's to the left, I have x log 6 minus 3x log 9 equals 4 log 6 plus 7 log 9. Now, what can I take out on the left? I can take the x out on the left. So I get x log 6 minus 3 log 9. And then finally, what would I do? So I get x is that over that. Yeah. Do you need to write this down?
Yeah.
Okay.
So if you expand, you still get the same answer.
Yeah. Wait, if you don't expand or?
No, like if you like use the actual number for.
Oh, the decimal.
Yeah.
Ah, it should be okay.
The answer should be minus 4.
Oh, it's just a minus, is it? Okay. Okay. Got that?
Yeah. The last step use the calculator, right?
Oh yeah, sure, for sure. Can I scroll down? Not yet. Okay, can I scroll down?
Yeah.
Okay, now, next one. Again, because of what we did yesterday, I think you can do this one. What type of equation is this? What type of equation is this? Very good. Yeah. I don't know if you can factorize it. You might need the formula. I'm not sure. You can try. Okay, you got that? Yeah? Does this have factors? Do we need the formula? We do? Okay. Why did I do this? Ex equals minus b plus or minus the square root b squared minus 4ac. 48, is it?
Yeah.
All over 4. What is it? 33. So look, you have two possibilities. Either ex equals 9 plus root 33 over 4,
Yeah.
or ex equals 9 minus root 33 over 4. And so how can I get the x out from this? Yeah. Log 9 plus root 33 over 4, or log 9 minus root 33 over 4. Now, yeah, these are both fine, aren't they? Yeah. What if it was negative? Is that what you're about to ask me?
Yeah.
Yeah, just reject the answer then. Yeah. 1.305 and minus 0.206. Is that right?
Yeah, minus plus
Okay. Can I scroll down? I see a few of you writing. Scroll down. Yeah, okay. Right. The next thing I want to do believe it or not, these types of expressions can be rewritten in the form of a, e, b, x, which is quite interesting. All exponentials can be written in the form a, e, b, x. So what we want to do now is, how do we write this in this form? Okay. Now we can kind of see, okay, well, I'll get started anyways. What I'll do first is I'll split it into 2, 4 times 2, 3x. Yeah?
Yeah.
And so this is equal to 2, 4, 8, 16 times 2, 3x like that. Okay? Yeah. This is equal to 16 times 8 power x. Because that's 2 cubed, you know? Now it's starting to take shape, isn't it? It's starting to look like a, e, b, x. But what's our problem? It's the 8, isn't it?
Yeah.
So what I can do is change the 8 into e log 8 x. Yeah. Yeah?
E.
You can check it on your calculator. If you type in e log 8, e ln 8, you do get 8.
E. How to calculate?
Type in e.
Where is E?
Yeah. Yeah. Now, what is ln 8, by the way, please?
5 point something.
I don't think it's that big, is it?
So 2.1.
2.1.
2.079.
Okay, we'll just do a little bit more. 2.079 x. There, we're done. This is exactly the same as this.
Why do you use
Good question. 2 things come to mind
Right.
immediately. Number one, we know how to graph these. We did them last week. How to draw the graph of this. Number two, when we do calculus, do you know calculus?
Yes, but whenever you
Mushtaka. Yes?
Yeah.
It's easier to get the derivative of this than it is of this. I bet you didn't know I was fluent in Arabic.
I know, it's I know what I mean.
Now the next example I want to do, I think I'll do at least two examples because the next one's a bit tricky.
Mm-hmm.
Yeah. Can I scroll down?
Yeah.
Yeah. Now, suppose you have something like log base 2, 7x minus 3, minus log base 2, 4x minus 6 equals 1. Good news, bases are the same. So that's nice because it means I can do this.
Yeah.
Log base 2, 7x minus 3 over 4x minus 6 equals 1. But before I go any further, there is a small problem.
Mm-hmm.
I first need to decide what my domain of x is. That is, I first need to check what values x can be. So if I was to look at the guy on the left, this tells me that 7x minus 3 must be positive, right?
Yeah.
So that means x must be more than minus 3 over 7. And likewise here, x must be more than what?
That's more than
6 over 4,
yeah.
which is the same as 3 over 2. Now just think about this. If I say x must be more than 3 over 7 and x must be more than 3 over 2, I can put those two together to make one statement. What statement would that be?
Second. Because
Yeah. If x must be more than 3 over 7 and x must be more than 3 over 2, then we can say x must be more than 3 over 2. End of
Yeah.
story. So x must be more than 3 over 2. Whatever answer I get must be more than 3 over 2. Okay. Right, now let's continue. What can I do next? Kind of, not quite cross multiply, I wouldn't call it that though. We can just use the definition of log. 2 to what power equals what?
What?
2 to power,
0.
no, look at the equation. 2 to the power of, oh come on guys. 2 to the power of 1 should equal 7x minus 3 over 4x minus 6. That's what this means. Remember the definition of log? It's saying 2 to what power gives me this? The answer is 1. 2 to the power of 1 gives me this. Yeah? Yeah?
Yeah.
I hope so. Now we cross multiply. 8x
Wait.
minus 12 equals 7x minus 3. That means x equals 9. Told you it was hard. imagine I tell you x must be more than 5 and x must be more than 8. Put those two statements together. What am I telling you about x?
Should be more than 5.
Nope. Because we just said x must be more than 8.
Yes, it's more.
If a number is more than 5, is it also more than 8?
Oh, okay.
Okay. Another example? Can I scroll down? Right, let's look at one with a small problem. Log base 9 x minus 2 minus log base 3. Now, what's the problem here? Base problem, isn't it? So, let's change the base. Which base will we change? 9. So using the change of base rule, oops, I should change the base 3. Then I have to divide by log 3, 9. This is using rule 5 from yesterday. Minus log 3, 6x plus 1 equals minus 3. Now what is log 3, 9? 2. So this is a half log 3 x minus 2 minus log 3 6x plus 1 equals minus 3. Now I cannot use my rule. Oh, I forgot to say at the start. X must be more than 2 and x must be more than minus 1 over 6. Therefore, x more than 2. Okay. Right, what was I saying? Oh yeah. Why can't I use my second rule of logs here? Yeah, correct. So I'll multiply everything by 2. But I still have a little bit of a problem, don't I? Because now I've just moved it to the other one. Yeah, now I can make it a square. Now I can use my rule. Equals minus 6. So, you can change this into saying 3 to the power of minus 6 equals x minus 2 over 6x plus 1 squared. Okay. Right, so we need to solve this one. This looks a little bit messy. What is 3 power?
1 over 7,
Yeah, what is that? 1 over
729.
Okay. X minus 2 over 36x squared plus 12x plus 1. So that means we get 36x squared plus 12x plus 1 equals 729x minus 729 times 2. 1, 4, 5, 8. So I get 36x squared minus 717x plus 1459 equals 0. Now, what the heck do I get for my x? I get two values, either x equals 2.30 or 17.6.
Six.
Yes.
Whew, tricky. Yeah.
So if you want to change the log 3 to log 9, it will just be the same.
Yeah, but it's a little. No, it's fine. Yeah, it's fine. I'm going to do one more example. Okay. Yes? Can I scroll down?
Yeah.
I'm going to scroll down now, Paolo. Okay. Next one now. Log x2 minus log 2x equals 3. And obviously x has to be positive. Okay? Right. Problem here is the x is in the base. I can use my flip rule that changes this into 1 over log 2x minus log 2x equals 3. Okay? I'm going to take everything to the right. Log 2x plus 3 minus 1 over log 2x equals 0. What can I do next? Multiply by log 2x, yeah. So this becomes log 2x squared plus 3 log 2x minus 1 equals 0. And what equation do I have here? Quadratic. No factors. I have log 2x equals minus b plus or minus square root b squared minus 4ac all over 2a. That's minus 3 plus or minus root 13 over 2. So then that means 2
Mm-hmm.
to the power of minus 3 plus or minus root 13 over 2 equals
X.
x. So there you go. There are the two answers there. So x equals 0.101 or 1.234. Scroll down. Here. Let me give you your homework to start. Homework 1 B C 2A 3 C 4 C 5A 6 A B C and D.
Teacher, do you know which is until to where is final
Exam,
result?
yeah.
Yeah.
It is 92 is the last page of the semester.
This semester.
Did you write those questions down?
No.
Yeah? Okay. Try these for a few minutes.
So in the math exam, in the final answer, if you write log, or write a number.
Depends on the question. So, for example, if they say exact answer, then that means they want something like this. If they just say answer, then that means this or this. You know? But sometimes they say round your answer. Maybe they might say round your answer to 1 SF. Then the answer must be 0.7. So it depends if they say exact answer, answer, or round your answer. Or they don't actually, I'm sorry, they don't use the verb round, they just use the verb give. Is that okay, Ming?
Yeah.
Yeah. Okay.